Okay, let's unpack this. Today we're diving into what feels like a hidden fault line between software and data engineering.
It really is. And it all boils down to one seemingly simple choice you make when you're designing a database table.
So set the scene for us.
All right, imagine a big table. I mean, millions of rows, high-frequency transactions. And on every single row, you've got two key timestamps.
Okay.
First is transactions. That's the moment your user actually did the thing, hit buy, submitted a form,
The event time.
the event time. And the second one is loading phase. That's the exact millisecond that piece of data physically landed on your disk.
And the big question that splits the two entire fields of engineering is,
Which one do you partition the table by? Your answer pretty much defines your whole engineering philosophy.
right, because the software engineer, traditionally, sees the database as a kind of a mirror of reality.
Exactly. A mirror.
If an event happened on a Tuesday, it should live in the Tuesday data. It's about keeping that user history clean, logical.
Yeah.
It's optimized for the what.
Which makes total sense if a human or an API is your main audience. But for a data engineer, that's not the world we live in.
For you, the database is more like plumbing.
It's a plumbing system, 100%. My primary audience isn't a person, it's the ETL process. It's a machine. So I have to care about the flow, the pressure, and the pipes.
So you partition by loadings.
You have to. You prioritize the system's health.
But hold on. Isn't that aren't you just making a mess for the analyst downstream? They only care about when the event happened?
That is the absolute crux of the conflict. And it's because of a really harsh reality we call late arriving data.
The mobile app that was offline for 3 days.
Perfect example. That app syncs 3 days later. Now, if your table is partitioned by transactions,
Yeah.
your ETL job has to go back in time.
It has to find that old Tuesday partition, unlock it, and stick this new record in.
And maybe even rerun calculations for that whole day. That is exactly where pipelines break. It's where you get duplicates, data corruption. It's just chaos.
Okay, so with loading time, that late record just lands in today's bucket.
Yep, it just arrives today. It's one clean, simple write, no going back in time. And if that reliability argument isn't enough, the financial one is even stronger.
Oh, I bet. You're talking about cloud bills.
We've seen six-figure mistakes here. Think about Google BigQuery. It charges you for the data you scan.
Right.
So if you partition by transactions and you want to be sure you have all the data, you have to re-scan the last 7 days every single time you run your job, just to catch a few late records.
Wow. You're paying to scan those same partitions over and over again.
Constantly. Whereas with loadings, you just scan what arrived today or maybe in the last hour. You guarantee integrity for a tiny fraction of the cost.
It's also about the write itself, isn't it? The fire hose effect.
You got it. With transactions, a sudden data dump means your system is frantically trying to write to like dozens of different historical partitions all at once. It's messy.
But loadings keeps it all in one clean sequential stream.
A single orderly queue. And that brings up the most important point. Trust.
Clocks lie.
Clocks always lie. You have time zones, system drift, users changing the time on their phone. You cannot trust transactions to be sequential or even accurate.
But the loadings, that's generated by your own system.
It's the only timestamp that is guaranteed to be sequential, immutable, and true. It's the rock your entire pipeline can be built on.
So how do we solve this? How do we bridge this gap between the two worlds?
You have to respect both needs.
Yeah.
The raw staging area where the data first lands, that must prioritize operational efficiency.
So you use loadings, you respect the pipe.
You respect the pipe first, land the data safely and cheaply, and then you do the pivot.
This is where you create the gold tables for the analysts.
Exactly. The data engineer's job doesn't stop at landing the data. The next step is to build a second, clean, downstream table that is repartitioned by the transactions.
So the analysts get their clean, logical, time series view of the world.
They get exactly what they need for the reports and models, and the system's core plumbing remains stable and cost-effective. You serve both worlds.
So the takeaway is pretty clear. Software engineering is focused on the what, the event. Data engineering has to focus on the when it arrived.
At least at first. So the final thought for you to take away is this. Next time you design a schema, stop and ask yourself one question. Am I building this for a human to read or for a machine to move?
Because the answer to that determines whether your system just reflects reality or if it actually works.